Today we are going to be discussing physical processes. That is your first major topic and objective. The essential question for the day is, why isn't the Earth one big flat mass? Like, why isn't it all just together and just all flat? That's what we're going to be discussing today. We're going to be looking at the physical processes that shape this. The first process we're going to look at is the Earth-Sun relationship. Not like a boyfriend-girlfriend relationship, like the sun isn't the Earth's bae or anything like that. But there is a relationship that goes on there. First thing I need to identify and get rid of misconception-wise is climate and weather are two different things. Climate is looking at like an average weather pattern. Weather is looking at like one event, like it's raining right now. That's weather. Climate is like we have a dry climate. We have a dry area because over time, on average, is dry. Okay, that's the difference between those two. More of an average, long look. Weather is like a certain snapshot, one point. Okay? A couple of key terms that go with the Earth-Sun relationship. First is the Earth's tilt. If you didn't know it, the Earth is not straight up and down. It is actually tilted. If I was holding the Earth on its axis right here, it would be tilted. Okay? It would be tilted 23.5 degrees to the north. These would be my poles, the North Pole and the South Pole, and that's probably a little bit more than 23.5 degrees, but you get the point. It's tilted. On its side, there's North Pole, South Pole. This affects the temperature. Okay, the tilt does. It affects the temperature because the sun is now hitting the Earth at a different angle than it normally would. So the temperature is affected from the tilt. Fahrenheit and Celsius, two different forms of measuring temperature. Next is the rotation. The rotation is, I'm holding the Earth on its axis. It is tilted 23.5 degrees. It is going to rotate on this axis, and that gives us day and night. Because in the United States, because obviously that's the United States, I mean, look at it. You've got the sun here. When it rotates on its axis, now China is getting the sun, and it's night in the United States. All right, next main point from the Earth-Sun relationship is revolution. This is the Earth actually revolving around your smiley face sun, because the sun's always happy, okay? It's the revolution. This affects the seasons of the Earth because now the position that the sun's direct rays are hitting the Earth is changing. Okay? The Earth orbits and revolves around the sun. The Tropic of Cancer is the dotted line here, 23.5 degrees north. It's north of the equator. The solid line is the equator. The dotted line is Tropic of Cancer. On June 21st, this is recognizing the solstice. This is the longest period of light for the northern hemisphere. This is when the sun's direct rays hit 23.5 degrees north. From then until September 23rd, the sun's direct rays are hitting 23.5 degrees north. So it's warmest in these areas. And then you have the indirect rays, which are hitting above and below that point. Then on September 23rd, as the Earth revolves around the sun, fall hits in the northern hemisphere. And this is where the sun's direct rays focus more on the equator. And then this area and this area are getting the indirect rays, so it's a little bit colder. And then as it revolves even more, and it's over here in this area, the Earth's tilt is pushing it here. And so the Tropic of Capricorn, which is this lower line, is getting the sun's direct rays. And the northern area is getting the indirect rays, so it's colder. So we have the winter. Now, moving away from Earth-Sun relationships and moving to the physical processes and the environment. Couple of different things we're going to look at. Actually, there's another side. First is tectonic forces. This is the Earth as it looked like with Pangea. These dotted lines are representing the different plates that are on Earth's surface. The Earth has different plates, and these plates are moving in different directions and sometimes towards each other because of tectonic forces. There's two key things that affect tectonic forces. First is gravity and then convection. Wrong word. Gravity and convection. What you have is you have a rock, which is the outer sphere of Earth, the lithosphere. It is setting on liquid mantle underneath the Earth's surface. And because of gravity, these plates, these rock plates, are moving. And because of convection and heat in the middle, it's liquid. And so this heat, as it's coming out, is making this movement happen as well. It's important for you to know that gravity and convection both play a part in tectonic forces. An easy way to remember that is like the oven, microwave convection oven, convection. Continental drift and plate tectonics are all referring to the same thing. Continental drift is the idea that these plates are making the continents drift apart. Some of them are slamming into them, like India into Asia. But that's the idea that it's talking about. These continental plates are moving. Plate tectonics is the idea that this all fits in, just different ways of talking about the same thing. Next in physical process in the environment that we're looking at is weathering. Okay? There's two different types of weathering, physical weathering and chemical weathering. Physical weathering would be like water seeping into a crack in the rock, and then that water freezing and that crack splitting. And now more water is going to get in there, and as it freezes, it's going to split. Okay? The physical makeup of the rock changes. It's pushing apart and then finally falls off. Okay? Chemical weathering is when the makeup of that rock changes. For example, if oxide gets into limestone, it starts to melt. Sometimes minerals might start to take on different shapes, all because of chemical processes. Next point with weathering is dealing with, or not with weathering, but with physical processes and the environment, is erosion. Weathering and erosion are two different things. There's three different types of weathering that we're going to, There's three different types of erosion that we are going to talk about. Wind erosion, glacial erosion, and water erosion. Wind erosion is when wind takes sediment and moves it. Okay? Sometimes people cut down a lot of trees, like deforestation. The trees have been there to block the wind, and they've also been there holding the soil together. And then when you take that tree away, the soil becomes loose, and the trees don't block the wind, and the soil moves. Okay? This happened in the Dust Bowl, not because the trees were cut down, but because farmers over-farmed areas. The soil was not held intact by the plants because it was dry, and then that soil was loose and started to blow. Okay, there's a couple of things that can happen. Number one, because of wind erosion, mountains can be eroded down. Okay, this erosion, this sediment can make them smooth at the top instead of these sharp peaks. Also, we have what's known as less. It's spelled L-O-E-S-S, but it's pronounced less, like I don't have more, I have less. What less is talking about is it's talking about the deposition, the depositing of the soil as it moves. So as this sediment is being brushed across and erodes this area, this sediment has to go somewhere, and sometimes it falls in an area, deposits in an area, and it's very fertile and can help improve farming. Next type of erosion is glacial erosion. What you can refer to this is like when there's a glacier on the side of a mountain. As it melts, it starts to recede, and then it freezes, and then it melts and it recedes, and it literally carves the Earth's surface out as it is melting and receding down. Another type of erosion is water erosion, and there's a couple of ways that this can happen. Number one, rivers and water can literally cut a path and carve a path into the Earth's surface, but also sediment can move across the bottom of a riverbed, and that big rock can be broke down into smaller rocks. Last major idea that we're going to get at is the four spheres. Okay? Lithosphere, atmosphere, hydrosphere, biosphere. The first sphere is the lithosphere. It's the land. It's the Earth's surface. It's the Earth's crust. This is where plate tectonics occurs. Now, there is a crust underneath the ocean. The ocean itself is not part of the lithosphere, but that crust underneath is still part of the lithosphere. It's the land. The atmosphere is everything that is dealing with the air. It's everything in the air. So weather patterns are happening in the air. Okay? Climate happens in the air. Birds are flying in the air. It's the gases that surround and envelop the Earth. Next sphere we're looking at is the hydrosphere. Root word there is hydro, means water. Okay? Part of the hydrosphere is the water cycle. If you didn't know it, we do not regenerate water. We have the same amount of water on Earth's surface at all times. Okay? It's in one of these stages here. You have water setting there. The water gets warm and starts to evaporate. As it's evaporated and it's sitting in the clouds, it's called a condensation. Then when there's enough condensation, it starts to precipitate down. It runs off of physical features and starts to pull up again. Then as it heats up, it evaporates, it condensates, enough condensation, precipitation, we got runoff back into the water, back to evaporation, and this cycle keeps going. Water does not regenerate, it is cycled. Then the last sphere that we're going to look at is the biosphere. This is the sphere that deals with life, animals, plants, and people. So the bird is flying in the atmosphere, but the bird is in the biosphere. The life itself is the biosphere. Trees are on the lithosphere. They drink from the hydrosphere, but they're still biosphere because they are the life. And then people, we literally walk on the lithosphere, the Earth's surface. We swim in the hydrosphere, so we don't fly in the atmosphere. I guess if you're in a plane, you do. But the people themselves are the biosphere.